Dear audience, good to be with you. Since we honed the talent of directing the business of education, we went more far to think about an inspiring name could be registered trademark for our efforts and these. Behold, in 2010, we came by our company Infinity, which we basically founded to tackle the profound educational and knowledge seekers' mind to get them a top quality of training services that buckle the global trends of a new working opportunities. Hence, we care about how we enrich our clients' demands for training by categorizing the concepts of learning, either technically or academically. So, we succeeded to reach our 5th anniversary with lots of fruitful feedbacks, which gave our trainees a solid trust and proved to us we can continue on the path that we dreamt of.
Today we are going to discuss one of the featured training diplomas of the Upstream section of Infinity, the Oil and Gas Exploration Diploma. Oil and gas, which are chemically a mixture of natural hydrocarbons, are natural energy resources of enormous economic importance. They provide fuel for transport and are vital for heating, lighting, and cooking. They are used in the manufacture of synthetic fabrics, plastics, fertilizers, detergent, as well as for many other purposes. We can simply subdivide the oil and gas industry into 3 major categories of stages. The upstream stages, which are getting raw oil and gas to the refinery. This category uses the available geological, geophysical, and engineering knowledge at the original site of the hydrocarbon deposits to reach and extract the oil deposits from its subsurface terrain. The second one is called the downstream stages, which are the refinery and processing processes. These stages are done after the transport of the ore from its original field site into the refining and petrochemical factories. These are mainly based on chemical treatments of the transported ore in order to extract different components of different economic uses. Finally, comes the marketing stage, or getting refined products to the consumers. The components of the upstream stages can be listed as follows. The exploration. The target of this stage is to use all the available geoscientific tools to find oil and gas pools, mainly to answer the following questions: which regions and which basins, which blocks were on the plot. The second stage is called the drilling stage. The first drilled wells are called exploratory wells, from which we can gather geological and geophysical data to enhance our subsurface image. The third stage is called the development stage. After the exploration stage has proved good indicators about the hydrocarbon accumulation, we can develop our field by getting more detailed subsurface image about where in detail are the reserves, what are the facilities to build, and will it be profitable or not. The fourth stage is called the production. This stage deals with how to manage the field and how to deliver the crude oil and gas. The exploration stage is the hardest stage of adventure. It is the most critical stage in the whole oil and gas industry. It involves very economically and risky decisions. The economic costs for this decision can be very expensive. For example, some wells can cost over than $200 million. So the most critical stage in the whole oil and gas industry is that which deals with the task of deciding where to drill and predicting what we will find before drilling. The answer to these basic questions represents the basic focus of exploration stage and the basic rules of geologists, geophysicists, and other exploration specialists who have to possess suitable skills and experiences in imaging and interpreting the subsurface required for the person in charge to take the suitable decision. Now, what about the rules of geologists and geophysicists in the exploration stage? In the reconnaissance survey, they try to answer the question about which basins offer the most promise. In detailed survey, they try to answer the questions about which blocks in those basins should we bid for, where on the block should we drill, and what should we expect from a particular well. For example, the type of hydrocarbon, the amount of recovery, the expected flow rates, and the risk of drilling at suggested positions. Now, about the development stage, we may need better seismic data to develop our knowledge about the subsurface. We want to understand where to place wells and to get the most for the least cost. To answer development questions, we need more detail on the reservoir, its properties, and the distribution of oil and gas. We need to improve our subsurface geological image by getting the more detailed subsurface seismic images. Also, at the development stage, we may drill some more wells during development before placing production platform to get more subsurface detailed image, for example, to confirm the fluid contacts, examine the reservoir heterogeneity, and will this pool be profitable or not. Now to turn about the rules of geologists and geophysicists at the development stage. To get more accurate detailed subsurface image about the fluid distribution, they try to get the detailed consistency image of the reservoir. They try to locate the wells to be drilled. They try to define the required sort of facilities or platform. At the production stage, the rules of geologists and geophysicists can be listed as follows. The management of the field to maximize the profit. Can we monitor how oil is being swept out of the reservoir? Evaluating the efficiency of injection wells and enhanced recovery. Is there more oil in the vicinity either at deeper depths or in nearby traps? And also, can we build a computer model of the field that matches existing production data? If so, we can test future recovery with different drilling scenarios. Now, about the value of geologists and geophysicists in general to any oil company, they work in two different sessions. To add hydrocarbon reserves by new discoveries, more from discovered producing zones, additional producing zones. The second session is to get the most reserves at the lowest cost, to invest in the right basins, to drill in the optimum locations, to correctly assess what can be recovered, to avoid unnecessary wells. During the last decades, there was technological expansion in geophysical methods, and this growth is continuing. New exploration frontiers and the exploration of complex and unconventional reservoirs are being made possible by recent advances in processing and acquisition methods. The assessment of reserves and resources through modern geophysical methods reduce uncertainty of the four main risk factors, namely the structure, the reservoir, the seal, and the charge. The precision and accuracy of interpretation of reservoir structure, the depth, shape, and lateral extent has been greatly improved through 3D seismic techniques. Seismic attributes such as amplitude variation versus offset have become an effective way to address reservoir risk. Analysis of differences in the reflection signal strengths can yield reservoir information, such as the lithology and fluid content. Let us now review an exploration's flow chart. First, we have to identify the opportunities, which is the most probable areas to capture hydrocarbon deposits. Second, we have to capture those opportunities. Third, we have to make seismic data acquisition. The seismic data are then being processed to enhance signal-to-noise ratio and resolution and achieve required spatial, temporal, and amplitude corrections. These processed data are then interpreted. At the interpretation stage, we interpret the subsurface and we will see features of interest, places where hydrocarbons may be trapped. More detailed work on some of these features may give us a prospect, which is a target we want to drill. We have then to assess each prospect and predict what we will find. Then we have to convince management to drill a wildcat, which is the first well in the area to test our predictions. If we find hydrocarbons, we may need to drill one or more confirmation wells to verify there is enough hydrocarbon for it to be an economic success. If we have enough hydrocarbon, we call it a field and pass it to the development or production department. It goes to development if a lot of money is required to build facilities. For example, a huge offshore platform and a long pipeline. If the new field is in an area with a lot of facilities already, it would go to the production department. Now let us review which careers does this diploma prepare you for. The first type of career is the well site geologist. Well site geology is a hybrid of applied geology on oil and gas well drilling. It studies rock cuttings and wireline logs from oil and gas wells to determine what rock formations are being drilled into and how the drilling should be proceeded. Well site geologist is geologist in charge on data acquisition from oil and gas well drilling operation. They are required to monitor vital operations during the course of the well, make sure that the well program are carried out to perform formation evaluation activities, and to ensure the well is drilled and evaluated in the most safe, efficient manner and cost effective. The second type of career is the petroleum geophysicist, and especially the seismic geophysicist. They can work at three sub-stages of seismic exploration. The first one is called acquisition geophysics. They take pictures of the subsurface much like X-rays reveal details of the human body. The second one is the processing geophysics, which develop and sharpen the picture and enhancing the signal-to-noise ratio. The third one is the interpretation geophysicist, who is responsible for using the sharpened picture to construct the shape of petroleum trapping deposits. Now let us review the rules of acquisition geophysics. The acquisition geophysicist is responsible for seismic data collection by the field seismic crew. Geophysicists determine how the program will be carried out, what energy source will be used, what recording instruments will be required, and ensure that the best and sharpest possible picture of the Earth is produced. These geophysicists frequently work for acquisition companies and divide their time between office and field work, often spending weeks at a time with field crews. There is opportunity for travel around the world, where they may live in field camps or small villages and face the challenges of working in the jungle, the desert, mountains, swamps, and offshore at sea. Acquisition geophysicists may also design and test new instruments, write computer software for field computers, or experiment with different ways of conducting the survey. The acquisition geophysicist in the recording tract or the dog house monitors the seismic data as it is recorded and directs the crew via radio phone. Now let us turn to the processing geophysicist. The processing geophysicist manipulates and analyzes recorded seismic data delivered from the field to enhance signal-to-noise ratio, achieve required spatial, temporal, and amplitude corrections, and turn the data into an image of the Earth's subsurface. They use computer programs to test and revise the data continuously. They consult interpretation geophysicists to ensure that all available geological information is taken into account, and the resulting image of the Earth is sharp and well focused. Now let us turn to the interpretation geophysicists. Interpretation geophysicists are involved in every aspect of the seismic work, from planning the survey, overseeing the data collection, and interacting with the processors through the final interpretation. They often go to the field to observe the data acquisition. Interpretation geophysicists interpret the seismic data using all the seismic geological information to determine the most reasonable picture of the Earth. Interpretation is done on fast interactive workstations and often projected onto large screens. Interpretation geophysicists frequently work as part of a team, which includes geologists, engineers, land negotiators, and computer specialists. They combine their talents to develop plays and decide where to drill wells to find new oil and gas reserves. Such teams exist in most oil companies. Now let us turn to another career, which is the mud logger. Mud loggers keep records of drilling operations to provide information about well status for the extraction of oil and gas. They help to increase the efficiency and the placement of wells, and the data they collect and monitor informs crucial decisions. They use a range of equipment and laboratory techniques such as binocular microscopes, ultraviolet fluorescence, and thin section analysis to create mud logs showing geological description of cuttings delivered from the site being drilled. They ensure that accurate samples are taken at the right intervals and records any issues encountered during the drilling. They mainly work offshore and are contracted to an oil company via a service company. Less commonly, they work in water well and mineral exploration. Now let us turn to another new career, which is the petrophysicist. Petrophysicists offer services in the areas of well logging supervision, log analysis and interpretation, integration of log data with lab data, computer analysis of logs, seismic modeling, synthetic seismograms, and the reconciliations of log data with geological, geophysical, and exploration prospects, field studies and simulations, reserve estimates, and submissions to regulatory agencies. These services are essential functions in modern oil and gas companies and can be accomplished without input from trained petrophysicists. The financial health and long-term success of a company depends on the central role of the petrophysicist in all aspects of the company's exploration and development activities. Now let us turn to another career, which is the petroleum geologist. The primary duty of a petroleum geologist is to analyze the data related to a physical location and for helping to find and extract petroleum. This is done by analyzing information such as maps, aerial photographs, data collected from seismic prospecting, and site-specific samples of rocks and minerals. Once he has interpreted the data, he will then collaborate with engineers to pick a suitable location and a method of test drilling. If deposits of petroleum are discovered, he will aid in developing methods of commercial extraction. They may be employed on the staff of large corporations, or they may work as independent consultants. Now let us turn to another K, which is the reservoir engineer. The main duties of reservoir engineer is the evaluation of field performance by performing reservoir modeling studies and exploring opportunities to maximize the value of both exploration and production. The working tools of the reservoir engineer are subsurface geology, applied mathematics, and the basic laws of physics and chemistry governing the behavior of fluids in the reservoir rock. Let us now discuss the value and the major components of oil and gas exploration diploma. This diploma will introduce you bit by bit to the various basic and advanced applications of geological and geophysical branches in oil and gas exploration. It focuses on how to integrate between different applied geological, geophysical sciences to make rich reservoir characterization and locating productive prospects. It doesn't need very knowledge of exploration techniques. It is suitable for anyone who wishes to gain a professional experience and qualification relevant to the oil and gas exploration industry. Our oil and gas exploration diploma is subdivided into two major categories, each of which is composed of a number of applied training courses. The first category is the applied geological modules. The second category is composed of applied geophysical modules. The applied geological modules include structural geology and geotectonics, sedimentology and stratigraphy, petroleum geology, subsurface geological mapping, and mud logging. Concerning the first module, structural geology and geotectonics, structural geology strives to solve causes and effects of tectonic processes to better image the geometry of rocks at the surface and in the subsurface. It is used in oil and gas exploration to define subsurface structural traps for hydrocarbons with log, seismic, and other data, such as gravity and magnetics. Now let us turn to the basic outlines of this course. It is composed of the following chapters: stress and strain, deformation processes, primary structures, brittle deformation, for example the faults, joints, fissures, and fractures, ductile deformation or folding, salt tectonics, regional tectonics, and at the last we will study the applications of structural geology. Concerning the second module, which is the sedimentology and stratigraphy, stratigraphic applications in the petroleum industry focus on characterizing the distribution and petrophysical parameters of hydrocarbon reservoirs, the seals that form traps for oil and gas deposits, and the source rocks that form the petroleum. Course logs and seismic data are used to calibrate and refine predictive models. Now let us turn to the basic outlines of this module. It is composed of two basic modules. The first one is the sedimentology. We will study in this module the following chapters: sedimentary rock classification, classic and carbonate depositional environments. The second module is the applied sequence stratigraphy. In this module we will study the following chapters: the unconformities, eostasy, sequence stratigraphic patterns, sequence boundaries and system tracts, sequence expression in well logs, and finally we will study the interpretation of system tracts from well log character. Now, concerning the third module, which is the petroleum geology. The basic outlines of this module involve the introduction to the petroleum geology, petroleum system elements, source, reservoir, seal, and trapping mechanism, types of hydrocarbon traps, structural traps, stratigraphic traps, diabolic traps, hydrodynamic traps, and combination traps. the generation and migration of hydrocarbon, reservoir dynamics, basic hydrocarbon prospection stages, and finally we come to the chapter of recovery. Now concerning the fourth module, subsurface geological mapping, the basic outlines of this module involve two sections. The first section is a manual section. It includes the thickness maps, isobath and isocore maps, the structure contour maps, the stratigraphic correlation. The second section is a software training, in which we will study the geological mapping by software Petrel. Now let us turn to the fifth module, which is the mud logging. The basic outlines of this module involve introduction to drilling operations, rigs, rig components and rig personnel, drilling process, hydraulics, mud data and mud systems, basic surface data logging, mud log and real-time measurements, and finally lag time applications. The second part of our exploration diploma consists of applied geophysical modules. These modules include seismic exploration and Petrel software training, well logging and formation evaluation and IP software training, well to seismic ties, and finally the reservoir engineering. Concerning the first module, which is the seismic exploration and the Petrel software training, seismic surveys are used to locate likely rock structures underground in which oil and gas might be found. The seismic technique can be subdivided into three major stages, namely the seismic data acquisition, the seismic data processing, and finally the seismic data interpretation. Now about the training course of seismic exploration in the diploma, it will consist of two basic categories, the theoretical and the manual one, in which we will study the seismic wave basics, seismic data acquisition, the seismic data processing, the seismic data interpretation, seismic attributes, and finally the seismic stratigraphy. The second section is the software training, which is a condensed seismic interpretation training by software Petrel. It will be around 2 full days. Concerning the objectives of our seismic exploration course, it is to understand the basic physical principles governing the seismic wave propagation, to recognize the different types of noises in seismic sections, to understand different techniques, sources, receivers, and the parameters of the seismic data acquisition, to understand the different process of seismic data processing and how to enhance and correct for the wanted signal, to be qualified in seismic data interpretation, structure analysis, and stratigraphic interpretation of seismic sections, to understand the uses of different seismic attributes, and finally the condensed training on seismic interpretation by using Petrel software. Now let us turn to the second module of geophysical modules, which is the well logging and formation evaluation module. Well logs are detailed record of the geologic formations penetrated by a borehole. These are comprehensive and important data gathered in any phase of well's history to identify petrophysical properties, which in turn defines the economic value of a reservoir. The techniques in analysis and interpretation of well logs are therefore essential in identification of hydrocarbon recovery. The basic techniques used in estimating the petrophysical parameters of reservoir involve the well logs, the core samples, the well tests, and the correlations. This figure represents a so simple typical well log interpretation sequence. First, we get the basic well log data, porosity, shale content, and resistivity from the composite. The lithology logs, for example, gamma ray and spontaneous potential, can provide us with information about the shale intervals and the clay percentage within the formation. Second, we estimate the effective porosity of the formation, which represents a porosity corrected for the clay percentage effect. Third, we enter the effective porosity together with the resistivity data into a saturation equation suitable for the reservoir nature to solve it for water saturations. Fourth, we can estimate the hydrocarbon saturation by subtracting the water saturation for percentage from unity. Now let us turn to the outlines of the well logging and formation evaluation training course in the diploma. It is subdivided into two main categories, the theoretical and manual one and the software training one. About the theoretical and manual, we will study the basic petrophysical parameters and the physical characteristics for formation evaluation of reservoirs, the core analysis, the logging operations, the lithology, porosity and resistivity open hole logging, the formation testing, electrical imagers and meters, the case hole logging, the logging while drilling, and finally we will study the petrophysical interpretation and how to evaluate the formations. The software training includes the formation evaluation training by interactive petrophysics software. Now about the objectives of the training course well logging and formation evaluation. Number one, to understand the basic petrophysical parameters for evaluating a reservoir, to understand the acquisition process for both wireline and logging while drilling measurements, to define lithology from the logs and know how the logs are affected by lithological changes, to characterize the reservoir based on interpretation of well logs, to be able to estimate petrophysical parameters from both of coarse and geophysical logs, to understand how to evaluate formations based on log data and core samples, and to understand the physical principles of both the basic and advanced tools used in logging. Now let us turn to the module of well to seismic ties. The well to seismic ties allows us to relate horizon tops identified in a well with specific reflections on the seismic section. The basic outlines of this module consist of well versus seismic data, preparing well data, preparing seismic data, construction of synthetic seismograms, well to seismic tie flow chart, and finally the well to seismic ties pitfalls. Concerning the fourth module, which is the reservoir engineering module, the basic outlines of this module involve the basic concepts, reservoir rock properties, reservoir drive mechanisms, the reserve determination, the BVT analysis, Darcy law and its applications. Thank you.